Hi, this is Anthony Clifton, and I am going to be demonstrating to you some code that I've written in Java for a game that I'm working on. As you can see here, we'll bring up the code. I'm using the NetBeans Integrated Development Environment, which is a great IDE for working in Java, PHP, C++, any number of languages. It's really nice because it will do things like auto-completion. It'll show you options when you're entering code, and it will warn you when you've made syntax or certain kinds of logic errors in your code. As you can see here, we load up some libraries here, most of those being for Slick2D. Slick2D is a library, it's a game development library that I'm using, and what Slick2D does is it acts sort of as a wrapper to lwjgl, which is the lightweight Java game library. Now the reason it has to act as a wrapper to that guy is because that guy is a wrapper for opengl. OpenGL is a graphics API for talking to 3D hardware accelerated graphics cards. OpenGL only knows how to do things in three dimensions. lwjgl provides Java bindings to work in 3D. However, my game is two-dimensional. And so I'm using Slick2D because what it does is it takes all the normal two-dimensional things that you might work with in a game, images, lines, sprites, and so on, and converts them into things like 3D textures, and then converts things like single pixel points into vertexes in the 3D environment. So you kind of need like 2 or 3 layers between Java and OpenGL to really get the job done. That's true of any programming language. It's just some of them go more directly by just going straight down to OpenGL. In this case, I have to use a couple layers. At any rate, Slick2D is really nice because it gives you all these nice classes to start from. Like this one is for basic game, and does most of the hard work for you of controlling the screen, of keeping track of sprites, updating sprites, and so on. And you can see here, we create a new game container. We set the display mode. We can control the update intervals for screen refreshes and so on. What's really nice about using OpenGL through lwjgl and then Slick2D is that you can get frame rates in excess of 200 frames per second, which if you just use the Java stuff like AWT or Swing or what have you, even with their full screen exclusive mode built into Java, it's really tough to get more than, say, 60 or 100 frames a second. But with Slick2D you can get 200, and it's even conceivable, if you keep your window small, to get 400, 500, 600 frames a second. This is where we initialize all of our game data. I'm loading in some images, as you can see, creating some surfaces for my character to walk on, loading up some sprite sheets, adding frames to the sprites so that they'll be animated, and so on. And then of course this is our update method, and update gets run automatically, and it basically updates all of your physics. So you can see here I have some gravity going on, and then I check for keyboard presses and do things based on keyboard presses. And then we have our render, which is where we actually draw everything to the screen. And so we do that as many times per second as the screen will allow. You can see here we have like simple draw commands. Here's where we draw the sky. And then down here we have various utility classes that I've created, or methods I should say, not classes, they're utility methods that I've created for doing various things in the game. So let's show you, and then here's my collision detector. It's very simple at this point. So let's show you the game. We'll run the program here. It compiles quickly. Takes a moment to load up all the graphics. And here is my little anime girl. Now, you'll notice up here that we're running at 75 frames a second. The reason for that is that I'm running this screen recorder, and it really slows things down a lot. Normally, frames per second would be about 225. As you can see here, my little anime girl has two boxes around her. One of them is the bounding box for her sprite, which is a little large right now, but that's okay. We'll fix that later. And then the larger one, this guy here, this is a movement box, which will probably end up being a little bit smaller, but I'll show you how it works here. As she walks around, her little sprite box moves with her. And as long as she stays within the movement box, the backgrounds don't move. But if she moves beyond that, then the movement box moves with her. And the reason that we have a movement box is, so that we're not scrolling the background all the time. We want to give her a little space to walk around. But when she does move, then the backgrounds move with her. And right now you can just see these lines that represent the platforms moving. Don't ask me what this red thing over here is. It's up here. It's just something that I put on the graphics so I could tell if my edges were getting aligned properly. You'll also notice here that you can tell what surface you're collided with. Each surface has a unique identifier, and if you're not on a surface at all, I'll jump here, it becomes -1, and if you're on a surface, it has the ID of that surface. You'll notice here I can jump and walk back and forth, and I can even sort of jiggle her a little bit. It's pretty responsive, really. Now, this game, it's a platformer, but instead of just scrolling the background whenever she moves, as you can see, she can move a little bit. This thing does parallax scrolling. So it can have any number of transparent layers, and those layers will scroll in a way that the farther away from the little avatar the background is, the less it moves, so that you get sort of a realistic 3D movement. And I'll show you that now. We'll just step her off the edge of this platform and let her fall. And you can see here that there's some mountains in the background. And we have to get over on the screen a little bit here before we start moving. But there we go. And if you notice, it's a little hard to tell, but you can see that the platforms move faster than the background layer does, and that the sky behind it, because it's essentially the same size as the screen, it doesn't move at all. So the bigger the background is compared to the screen size, the less it moves. Now we'll just have her jump. I'm going to go ahead and turn off these boxes here. There we go. So that we'll set debug to false there, so that we get a little more realistic behavior, so you don't have those boxes distracting you. And as you can see, she can kind of walk around and jump on platforms, and the background scroll. And I can have any number of background layers, all of different sizes, and I can really create the sense of sort of a 3D environment that she's exploring. Now my next steps in this game are to get some monsters in here, get some monsters moving around on these platforms that she can encounter and fight, and then to give her some weapons and some ability to fight them in some way. And then do some collision detection on them so that I can determine if she got hurt or if she hurt the monsters. Just do a little thing here again. You can see she has a little jump. I need a little jump sprite in there too, something to indicate that she's jumping. And then a little sprite for when she lands. But for right now, this gives a pretty good idea of what's possible. In just a, I don't know, it's about 300 lines of code, 400 lines of code, actually have a not, half bad looking little game, all things considered. That's what I have to show you for right now. I'm going to go ahead and exit this, and there you go. Thanks.